Welcome to the Memento pattern, one of the gang of 4 behavioral patterns. By the end of this video, you will know what problem it solves, who the 3 participants are, how to write one in TypeScript, and just as importantly, when you should skip it entirely. Imagine you are building an editor with an undo feature. To roll back a change, you need the object's previous state, but that state lives in private fields. If you reach in and read those fields from outside the class, you have broken encapsulation. Every caller now knows the internal structure, and any refactor of that structure breaks every caller. The challenge is to save and restore state without that coupling. Think of it like writing private notes and sealing them in an envelope. You hand that sealed envelope to a filing clerk for safekeeping. The clerk stores it and gives it back on request, but never opens it. The contents remain yours alone. That sealed envelope is the memento. It holds your private state, but only you know how to read it. The pattern defines 3 participants. The originator is the object that has valuable internal state, a text editor, a game character, a form. The memento is an opaque snapshot that the originator creates from its own private fields. The caretaker, often a history stack or an undo manager, holds on to mementos and hands them back when needed, but it never inspects or modifies the data inside. Encapsulation stays intact, because only the originator knows how to interpret its own snapshot. Start at the top. Editor memento is immutable. It takes a string in its constructor and exposes it only through getState. Nothing outside can change it. Next, editor is the originator. It owns a private content string. The save method creates a fresh editor memento from that private field. The restore method reads back from a memento and overwrites content. Both operations live inside editor, so private state never escapes. History is the caretaker. It holds a stack of editor memento objects and only knows push and pop. It has no idea what a memento contains. In the client code we type, hello, push a checkpoint, then type, world. Calling pop retrieves the snapshot and restore brings the editor back to, hello. The undo works, and history never touched the private content directly. The flow is a simple two-way handshake. When the user triggers a checkpoint, the originator packages its private state into a memento and passes it to the caretaker. When the user hits undo, the caretaker pops that memento and hands it back. The originator is the only one that unpacks it. The key decoupling is that the caretaker is completely blind to the data structure inside the memento. The main cause to watch out for is memory. If each snapshot copies a large object and users can undo hundreds of steps, the history stack can become very expensive. Use memento when you genuinely need multi-step undo, transactional rollback, or a full state history, and when that state must stay private. It earns its complexity in those cases. Skip it when your state is already a simple value. You can copy directly, when one backup field is enough, when snapshots would bloat memory, or when you already have a command pattern whose commands can reverse themselves. In that last case, you get undo for free, without storing any snapshots at all. To summarize, the memento pattern lets an object save and restore its own private state by packaging it into an opaque token called a memento. The originator is the sole reader and writer of that token. The caretaker manages storage but stays blind to the contents, preserving encapsulation. And remember the practical trade-off. Each snapshot uses memory, so deep undo histories on large objects can get expensive fast.